and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to the second lesson about synthetic polymers. In the last lesson, we learned about the addition polymers called polyethylene and polypropylene. We learned about the chemical equations showing their polymerization, their applications, and their environmental impact. In today's lesson, we will learn about Pvc and Perspex. We will discuss their uses and their manufacturing process. If you are ready, students, we will get started. Let us begin by discussing polyvinyl chloride. Polyvinyl chloride, commonly known as PVC, is the third most widely produced plastic after polyethylene and polypropylene. PVC was accidentally discovered at least twice in the 19th century. On both occasions, it appeared as a white solid inside flasks of vinyl chloride that had been exposed to sunlight. It was only in 1926, however, when the tire company, B.F. Goodrich, developed a method of softening PVC. The result was a flexible and easily processed material that quickly went into widespread use. PVC is a thermoplastic polymer, which means that it turns to a liquid when heated and becomes almost like glass when it is cooled. It can be made softer and more flexible by the addition of a group of chemicals called plasticizers. PVC is constructed from repeating vinyl groups called ethenols, which have one of their hydrogen atoms replaced by a chloride group. PVC is commonly used in construction. This is because it is very durable, relatively inexpensive to produce, and easy to assemble. Once it has been treated with plasticizers, it is also used to make clothing, upholstery, toys, hoses, flooring, and many other commercial items. In fact, it is estimated that the PVC industry is going to produce more than 40 million tons of synthetic polymer by 2016. Students, let us pause for an activity. Here are three polymers. Which of these describes PVC? How can you tell? Take a few minutes to write your answer.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I am confident that you came to the correct conclusion. The correct polymer is C. That describes the molecular makeup of PVC. The simplest way to tell is to think of PVC's full name: polyvinyl chloride. Obviously, a polyvinyl chloride must contain chlorine, and the other two polymers do not. Therefore, the correct answer can only be C. This question may have been easier if you recognized the other two polymers from the last lesson. They are polyethylene and polypropylene. Great work, everyone. Now, let us turn our attention to Perspex. Perspex is also sold under the names lucite, acrylic glass, or plexiglass. Its chemical name is polymethyl methacrylate, or PMMA. It is a transparent thermoplastic, which is often used as a light and shatter-resistant alternative to glass. The polymerization process for Perspex was first discovered in 1877. In 1933, the German scientist Otto Röhm first patented and sold it under the name plexiglass. It is an economical alternative to another synthetic called polycarbonate, which is stronger but also more expensive than Perspex. In addition, it does not contain the harmful subunits called bisphenol A. Perspex is commonly used because of its easy handling and processing, low cost, and relatively high strength. Perspex does have disadvantages, however. It can shatter under a sufficiently high impact force. It also scratches more easily than glass. Nevertheless, it is frequently used when a substance is needed that is both lighter and tougher than glass. For instance, the windows of airplanes are made from Perspex. So are most exterior lights of automobiles, the visors of helmets, and different types of medical equipment. Aquariums also use Perspex to make their tanks. Some aquariums have tanks with walls that are almost half a meter thick in order to withstand the huge water pressures. Now that we have studied both PVC and Perspex, it is time for another activity. Using what you have learned, students, please write the chemical equations for the polymerization of both vinyl chloride and methyl methacrylate.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I'm sure you had no trouble in completing this exercise. Here is the chemical equation for the polymerization of vinyl chloride. This is the chemical equation for the polymerization of methyl methacrylate. Do these match up with your own equations, students? Great work. Be sure to double check with teacher if you have any questions about the compositions of Pvc and Perspex. Today, we have learned a great deal about two synthetic polymers. We have learned the Pvc is the third most widely produced plastic, that it is thermoplastic, and that it is made softer and more flexible through treatment with plasticizers. We have learned that it is produced from ethanyls, which are vinyl groups which have had a hydrogen atom replaced by a chlorine atom. We have also learned about Perspex. We discovered that it is sold under many different names, and that it is a lightweight and shatter-resistant alternative to glass. We learned that it is easy to process and handle, fairly strong, and relatively inexpensive. Following this lesson, teacher, please hold a class discussion about the different uses of Pvc and Perspex. I am sure that everyone will find such a discussion useful and informative. That brings us to the end of the lesson. Until next time, thank you, teacher. Thank you, students.